Hey ladies and gentlemen, today we are starting some information about statistics, data analysis, and specifically scatter plots and correlation. So with today's notes number 6, I'm going to just kind of talk about bivariate data. The reason it's called bivariate data is because we're going to be comparing X values and Y values. Okay, and here's a table of that as well. They are data collected on two variables instead of one to establish whether there's a relationship between the two variables. Relationship is that key word, again, talking about associations and correlation. So what we have for our first example, a survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to create a relationship between a day's low and high temperature. What I'm going to have you guys do right now is part A on your own. Okay, construct that scatter plot of this bivariate data on this grid. So, if you have 2649, we're going to go, this is 20, 22, 24, 26, 49. So if this is 50, right below. Okay, and I'm going to have you pause the video and do that. So when it is unpaused, you'll see that I already have mine done. So again, please pause. So here is mine. Okay, so mine is has some extra stuff on it. You'll get to that here in a little bit. But I also wrote down just kind of how it changed, and you see all of my points are here. Part B says draw a line of best fit. And so for Part B, what you're going to do is draw your line. It could be exactly like mine or as close to mine as possible. Now, mine does go through this data point up here at the top, but I have about 1, 2, 3, 4 points below, 1, 2, 3, 4, 5 points above. So it's very close, very similar. It does not intersect the y-axis. It does intersect the x-axis at, I would say, about 3, okay, and through this top point. So go ahead, create that. The next thing that we are going to do is calculate the slope of the line by picking off 2 points, not necessarily the data points. So the 2 points that I chose, okay, are 32.56, okay, 32.56 right there, and then I took 40 and 66, okay. So to find slope, remember it is the change of y over the change of x. And so I put it into my formula. Okay, so 66 minus 56, 40 minus 32. And then you simplify. I have 10 over 8, and I'm going to have you calculate all the way down till we have 1.25. Okay, so to leave your answer, I know sometimes I say leave it as 10/8 reduced or simplify all the way down. This would be considered a unit rate. It just depends on the question, okay? So really show all work, and then you're good to go. The next thing that it says is use your line of best fit to estimate the high temperature for a day in April given that the low temperature was 42 degrees. Illustrate your answer on the graph. So what I have is at 42, this is where I have my dotted line. I created a dotted line up to my line of best fit, and then I went across to figure out my y value, and I found my y value to be 68 degrees. Okay, so for a low temperature 42, so we are writing sentences, our line of best fit gives a high temperature of 68. This is shown by the dashed lines, okay? You don't necessarily need to put this last part in, but this is more for me since it's the answer key. Okay, so I'm going to move on. If you need to write, just pause. Letter E says, would you characterize the relationship between the low and high temperature as a positive correlation or a negative correlation? So we're going to explain. So we do see that we have a positive slope, right? We'll go ahead and write in that this is a positive correlation because as the low temperature increases, the high temperature increases, okay? So and we talked about this in previous notes. The two variables are moving in the same direction. You don't need to have that, so we can put that in parentheses, but if you do, that's great as well. I'm going to flip it over to the back, so if you have more that you need to copy down, please pause. over on the back, okay, we have two variables can have a strong relationship with one another as seen on the scatter plot, but might not have a causal relationship. A causal relationship exists when the change in one variable actually causes the change in the other, okay, and that's not always the case. So we're going to read some scenarios, and we're going to decide whether the points have a strong correlation, okay, where the data falls almost in a line, and then we're going to determine if there exists a causal relationship between the two variables. So if so, what variable causes the other? So we'll kind of get through this together. Our first question is the high temperature in New York City and the number of water bottles sold. So the question is, does one cause the other? Okay, so what do you think? So think about that real quick, and then I'll show you what we came up with. So hopefully you thought, yes, it is a causal relationship. When the temperature increases, people get thirstier, and that causes the number of water bottles sold to increase. You do need to make sure you have this. You have to kind of explain, well, what is that cause? Temperature increases, people get thirstier, right? And that causes the number of bottles sold to increase. So pause if you need to. I am moving on to B. So 4B, a person's height and a person's shoe size. Does the person's height, as that changes, does that change the shoe size to change, or vice versa? So think about that. Let me know what you think. This one's kind of tricky. It's no, okay? There is no relationship because even though they're positively correlated, as the height increases and the shoe size increases, one does not cause the other, okay? Kind of as your body changes all around, that is your cause, okay? So typically as your age increases, not always, but there's more factors to that. Part C, a person's weight loss and the number of hours a person spends at the gym per week. So, as a person is losing more weight, could that cause them to spend more time in the gym, or vice versa? As they are spending more time in the gym, could that cause a person to lose weight? What do you think? Okay. So hopefully you are thinking, yes, there is a causal relationship. Okay, the more hours a person spends at the gym, the greater their weight loss. Okay, so hours at the gym causes the person's weight loss. Okay, go ahead and copy this down. This is going to be a short video. I'm stopping it. We are going to do the rest together next time I see you in class. Okay, that's it. See you guys later. Have a great rest of your day.